So let's say we have this array here. This is a 2D array of numbers, and it's called road. Picture this as a road, basically. And picture these ones as cars. They're just cars on the road. Now we have a car here, of course a car here, and so on. Now we don't know the direction that these cars are moving. We just know that they're cars. Picture it as a snapshot of a road, let's say. So I don't know if this car right here is going to the left or if it's going to the right. I don't know if this car is going down or to the left or right either. So given this snapshot, and let's say given a position of a car, let's say this car that I'm highlighting right here, what I want to do is find all of the other cars in this road that are a possible collision course, with this car. So what does that mean? Well, basically, if these cars, we're going to make a few assumptions here. The first thing we're going to assume is that these cars move at the same speed. Let's say they're all self-driving cars. They're all going at the same speed. Now, if they're going at the same speed and you don't know the direction that they're going, then a possible collision course of this car would be this car right here. Because notice, if this car travels to the left, this car here travels down 2 spaces to the left, 2 spaces down. They meet right here, and that is their collision. That's a collision course right there. And of course, this car, if this were going down, and if this car were going to the left, then they meet here. It's a collision course again. So what's going on here is that the question we're really asking is, given a car, given a point on the road that is a car, what are all of the diagonals to that car? That is a question that we're really asking here. So you see how when you're given a question, it could be a real life scenario, it could be an interview, doesn't matter. You get a lot of abstract or sort of details that come along the way. And the first task is to reduce it down to what is the question really asking from an algorithmic perspective. So let's get started. I want to start by creating a function, and we're going to call it get collision points. So these are all the collision points given a road, and let's call it a location of a car. This right here is my function. Now I want to develop this in a methodical manner. So what I'll do is I will right away do a console.log. I will invoke my function. I will pass in the road, and let's say I pass in a row column pair denoting the location of this car right here. So I do 2, 3. This is row 2, column 3, both indexed as 0. That leads to this 1 that I'm highlighting right here. Okay, so given this, I want to return some collection of coordinates of all collision points. So before we get started, what do we expect our algorithm to return? In comments here, I'll just specify some sort of collection here, and I'll specify the coordinates of all of the ones that we just talked about. So this one right here is a diagonal to this one. That one would be essentially row 0, and it would be column 1, like that. And then this one right here, that would be row 3, column 4. So let's do that, row 3, column 4. And also this one here, this one is also a diagonal to our target right here. And that would be row 0, 1, 2, 3, 4. That'd be row 4, column 1. So let's put that in here, row 4, column 1. Okay, so this is what I expect my algorithm to return. So right away I know that I want to return a collection. So why don't we start by actually defining a collection. We'll call it collision points. We'll make it have an array, or make it be an array rather, and we'll just return it for now. And I want to just invoke this function, and I want to get, as I expected, an empty array. So far, so good. Okay, now comes the actual work. So let's see what's happening here. So I'm given this point right here. That's my location. Now, I have 4 directions that I can go in. I can go to the bottom right, the bottom left, the top right, or the top left. 4 directions, right? So we can start by first checking, let's say, the bottom right. If I were to go to the bottom right, then I go to this one right here. What I'm effectively doing there is I'm incrementing both the row and the column indices. So once again, if I go to the bottom right, that means I increment the row by 1 and the column by 1. That is going diagonally to the bottom right. That's what that is. So we can even start by defining some variables. In fact, I'll use a let because I'm going to change these variables. You'll see shortly. But I can even destructure this for now. I'll say my row and column equals the location that I'm given. So the location that I'm given, remember, is a 2, 3. So this is my row and column. Remember, I want to increment row and column by 1. That is equivalent to going to the bottom right diagonally. So let's go ahead and do that. So I want to increment, once again, row and column by 1 while I'm within the bounds of this road here. Because I don't want to keep going. I can't go off the board, right? So I want to do it while I'm within the bounds. So I said while. That equates to a while loop here. So let's go put it inside a while loop. What we're saying is, I want to do this while the row is less than the number of rows in our road. So the number of rows in our road will be just the road dot length here. Let's just do that. And also, while the column is less than the number of columns in our road, and that just acts as that with a 0, just standard way to get columns and rows of a rectangle. So that's that. So we have our while loop here. And now what we want to do is ensure that while we do our pluses, we want to increment our rows and columns. We want to push coordinates into our collection points. Now we don't want to push just any coordinates. We want to make sure that we only push it if it's a 1. Remember, we're looking for cars that are collision points. So if this were a 0 right here, then there's no car there for it to collide with. So there's nothing there. Only if it's a 1, right? It's a collision point. It's a possible car that has a possible collision course. So I want to check, is the element that I'm looking at a car? And that would just be check within the road, check the current column, the row and column of the road. Is that equal to a 1? In other words, is that a car? And if that's a car, then I want to push it into my collision points array. Now, what do I want to push? I want to push some sort of, in this case, I'll just push it in the form of another array here. This is sort of representing a coordinate, but this could be really anything. But you see here, I've just pushed in a coordinate right now. Now, obviously, this while loop, we don't want it to loop forever. So I want to increment the row by 1 and then the column by 1. Remember, we're going to the bottom right. In fact, I'll just put this in comments here. I'll say bottom right. In fact, bottom right diagonal, like that. Now that's what we're doing here. So if I were to run this code, I expect my collision points to have this coordinate right here, and that is 3, 4. So let's see what it has. Okay, that's strange. So we have just gotten just our empty array so far. So let's go ahead and debug this. So far, so good. We have our let right here. Okay, fine. We're saying while the road is less than the length and that, if the current thing equals to a 1, then I want to push it in, and then all the while, increment row, increment column. First thing we want to do, let's check if we're even getting inside this while loop here. So I'll just say in here, so basically I'm just walking you through how to think about debugging as well, right? So let's go ahead and see if we're even in that loop. Okay, so it looks like we're there. That's good. Well, then let's see if we're even getting inside right here, inside this if statement. So it looks like we are getting inside the if statement. Interesting. So what I have here, I should have returned my collision points. That's silly. So let's go ahead and do that. Now take this away. We should be getting exactly what we want now. So let's go ahead and check that. Okay, so this is interesting. We have the 3 and 4, but we also have the 2 and the 3. So what's going on here? Basically, the 2 and the 3 is the original location that we were given. Now, we don't want to add this, obviously. This is the car that we're given. A car cannot collide with itself, so we don't want to include that in our answer. But why is it that it's coming in our answer? Well, first of all, remember, we have the row and the column destructured to capture the location. And then what we're saying is, while it's within the bounds and it's a 1, then I want to add it. But at this point here, I'm still at the very first row column that I was given, the 2, 3. I haven't yet incremented it. In other words, I haven't yet gone to the bottom right. So why don't I start by orienting myself in that direction first? So I'll go ahead and do that. So in fact, what I'll do is we can reform this line right here. I'll start by saying let row equals the location, the 0th position of the location, but plus 1. Remember, that means we're going to the diagonal bottom right. And similarly, I'll say the column equals the row at the first position, again, plus 1. So at this point here, I've already reoriented myself toward the bottom right. That's that. Now, this is interesting because if I were to run this code right here, you see it gives me exactly what I want. It gives me the 3 and 4, but there still is a problem here. The problem is I'm given 2 and 3. If we go back up here, 2 and 3 is this right here. Now, what if I were given this 1 right here? In other words, what if the input were 3, 4? See how here, I just want to run this code. I'll show you what happens here. Now we get something empty here, and that is interesting. So what we have here is the row plus 1. What does that mean? Well, that means 4 and 3, 4 and 5, like that. 3, 4, going to the bottom right is 4, 5, right? That's that. Well, 4, 5 is outside the range of this road right here. So this would be 4, column would be 5. While we are within the range, this while loop wouldn't even enter. There'll be nothing in this while loop. And we can test this out too. We can see if we're even going in here. So I'll do a console log. Just like that. And it's nothing. So we're not even entering this while loop. Okay, fair enough. But we do expect our answer to have not just nothing, but we want it to have the 2, 3, right? Well, fine. So we want to go also to the top right, the top left, and the other direction, the bottom left. So we're only going to one direction here. So now let's go to the other directions. So what I'll first do is I want to go back to 2, 3. This is an example that we're going to work with here. And I want to run this code again and show you that we have just one direction here. Okay. Now, if we were to go in other directions, let's say we start to go to the bottom left. Now, what I could do is take this chunk of code here and copy it and just obviously move things around, meaning going to the bottom left would mean that I would decrement my column by 1 each time. But do you see here how right away, very quickly, this code becomes very repetitive? I'm repeating a lot of logic here. In fact, I also have to repeat this logic here and reorient myself to the bottom left. Again, this makes for sloppy code, so we don't want that. So let's take this away again. And now let's ask ourselves, what is the code that we are repeating over and over again? Well, it's a while loop and it's also the orienting in the direction. Now we know that we have 4 directions that we're going in. Again, bottom right, bottom left, and top right. What we could do is actually define a variable and it's called directions. And this variable is an array. And this array holds our 4 directions. It takes up a constant space. So let's say it goes to the bottom right. That is 1, 1. That is increment row by 1 and column by 1. And then let's say we go to the bottom left bottom left will mean I increment the row by 1, but I decrement the column by 1, like that. Now let's say I go to the top left, which means I decrement both, like that. And then lastly, if I go to the top right, what would that mean? That means I decrement the row, but I increment the column, like that. So these are my directions. Now what I could do here is iterate over these directions, because these are 4 directions I'm going in, and I already know that I got to check all 4 directions. So I could simply do a loop here. In fact, I can use a for each. I don't have to use a for loop. And I'll just say for each direction, in direction, what do I want to do? I want to do the logic that I already have here. So we'll start by first taking in the bulk of our work, which is the while loop right here. Now I have this while loop here, so I'll just take away this stuff right here. Now what am I saying here? While we're within the bounds, I want to push if we have a 1. Now I'm saying row plus plus column plus plus. Again, this only works if we're going in the bottom right direction. But the whole point of directions here is to go in our directions in a dynamic fashion. So if I were to go to the top left, let's say, it's not just that I have to look for the bounds, but it's a different limitation that I have. In other words, if I kept decrementing row and column by 1, I want to do so, but I don't want to ever go lower than the number 0, right? So that's a new limitation that I have to place on the while loop. So not just I have to ensure that the row doesn't exceed the rows and columns don't exceed columns, but I want to also ensure that the row never falls below 0. In fact, it's equal to or greater than 0. And what I'm doing here is I'm putting separate lines in our while loop, just making it more readable. So I'll just say column here, like that. Okay. What I've done here essentially saying is this accounts for all directions now. So while our row and column is within the entire bounds of this road that we are given, we want to do some work. We want to, as long as it's a 1, push inside collision points. But remember, this row plus plus column plus plus, this only works if we're going to the bottom right. So we have to do a little something different here. So we still have this logic that we have to apply, because remember, we have to orient ourselves in the direction that we are going in. So I'll take these 2 lines here, and I'll just throw it up right here. Now, why am I putting it right here? Because remember, for every new iteration of these directions, we are going in a new direction. That means at this point, I'll just type in here, we want to orient ourselves in the new direction. So in other words, this row is location plus not 1, because this only works for the bottom right. So what I could do is use the direction that we're already given here, and I'll just access that as 0. And then for the same thing for columns, access that at 1. What I'm saying here is that if we are going to the bottom right, then it's location plus 1. Same thing, location 1 plus 1. Now if we're going to the top left, then it's location plus -1, location plus -1. In other words, location is being decremented if I'm going to the the top left. So this right here orients you automatically without you having to apply any manual logic to that. It's already there. Now moving on then, still this logic here only applies if we're going to the bottom right. So it's very simple. I just take what I've done already and I say row increment or decrement, doesn't matter, update the row by the direction that we should be moving in. And the same deal for the column. Update the column in the direction that we should be moving in. Again, if this were negative, this is equal to decrementing. And that's that. So this right here is our new logic. Now if I were to run this code, look at this. So I get exactly what we want. We get 3, 4, 4, 1, and 0, 1. The order doesn't matter here, but we captured all that we wanted. Essentially, we've gotten all of the diagonals for a given car in our road. And now put more broadly, we have gotten all of the cars that are in possible collision courses with our target car. So notice what we did here. We started out with an algorithm that was pretty simple, but it got repetitive real fast. We identified the parts that were repeating, and we created variables, in this case arrays, to reduce the repetition, make our code less sloppy, make it easier to understand and read and maintain, and make it more compact. All the while, we also looked at a little bit of debugging, because for a while, remember, we weren't returning the correct thing. So with the debugging, we put in print statements in strategic points to determine whether specific points of our code were being reached. So we covered a lot here. So hope it all makes sense. And that's that.